Hi friends, in the previous videos we discussed about the conventional brake system, its functioning of its critical parts and the ABS, that is anti-lock brake system. This video I am going to talk about the OCDB, oil cooled disc brakes, the system which is used in the construction and mining machines. Oil cooled disc brakes, OCDB. What is meant by OCDB and where this kind of brake system is applicable? When you see the larger capacity machines like these mining trucks, you can see, and wheel loaders, braking system or braking mechanism, braking occurs by the multiple disc weight clutches. These are called OCDB. Why specifically these heavy vehicles needs the OCDB? Why not the drum brakes or the disc brakes? Because these vehicles weighs right from 60 tons to 500 tons. Whereas the commercial vehicles or the passenger vehicles or the transport trucks may weigh hardly from 1.5 tons to 40 tons maximum. So look at the difference. Where is the 1.5 tons to 40 tons and where is from 60 tons to the 500 tons. Imagine if you want to stop these vehicles of 500 tons or even 100 tons vehicles, what is the size of the brake drum or brake pads you need to stop this efficiently? Further, the another point to be considered is these vehicles run on very challenging roads, mining roads, steep gradients. Sometimes vehicles will carry the load under the steep gradients, down gradients. So an efficient braking system is required to stop these vehicles. So with greater contact area and with greater hydraulic force. The main parameters of braking is the contact surface of the friction material. That is, in case of the disc brake, it is the caliper brake pads and the disc contact area. In case of drum brakes, the friction surface which is contact into the drum. Same way, to stop the bigger machines, the larger brake contact area is required with greater braking force. So if we want to make such drum brakes or disc brakes, these machines need very big brake drums and with very high pressure and a very large circuit. So here the requirement is we have to provide the greater brake contact area in a confined space. Greater brake contact area in a confined space. That is possible with the multiple disc brakes like this. These are the multiple disc brakes. In fact, these are identical to the clutch packs in the automatic transmissions, what we have discussed in the transmission case. Okay, you can see this animation. A series of clutches like this. This is the friction plate with internal tangent teeth, and this is the metal plate or the steel plate, are arranged alternatively in a complete casing, which I will be explaining now. And the actuation of releasing or holding the brake is taken care by the hydraulic fluid. The oil cooled disc brakes looks like this. You can see this is this one and this is the magnified view of this arrangement. you see like this is the wheel, this is the wheel hub, okay, having splines over it. This is the fixed housing which will not move, whereas this will rotate along with the wheel axle. This is how it looks. See these plates in the clutch plaque, the friction plates having internal tangent teeth like this and arranged on the splines of a hub connected to the wheel axle. Means when the axle is rotated, this hub also rotates. Along with the hub, this friction plates also rotates. But these friction plates will slide freely over these splines. So when it comes to these steel reaction plates or plates having external tangent teeth are placed in this housing. This is the fixed housing which will not rotate, which is fixed to the axle housing. But these plates will move freely over the splines of the housing. Both this complete plaque is supported with two pistons as I explained you. This pink one is the service brake piston and this yellow one is the parking brake piston. And these both the pistons are supported with the springs, coil springs surrounding to this. This one row of springs can be supporting to the parking brake piston, the other row of the springs are supporting the service brake piston. You can see the oil passages here to the service brake, and somewhere here the oil passage like this is to the parking brake piston. Now it is clear how this OCDB oil cooled disc brakes looks. Let us see what happened. When the vehicle is running, means when the vehicle is running, the lubricating oil or the hydraulic oil will be circulating in this complete clutch pack. So lubricating this, separating the friction plate and as well as the steel plate, and also doing the other job, that carrying whatever heat is generated between these two plates. The heat is generated between these two plates is carried by the lubricating oil continuously and thus comes from a pump and goes to a cooler, cooled, and again it will be recirculating. So the clutch pack is in released condition. The pistons are like this actually. So this piston is supported with internal spring with this, which is supported to this pin, and whereas this parking brake piston is supported with the tension of the larger spring which is shown here. As I told you, I have shown the oil passages to this service brake piston and as well as the parking brake piston. Vehicle is running. What happens when the vehicle is running? See this here. When the vehicle is running, the oil is coming, always oil with certain pressure will be available in this cavity between the parking brake piston and here in this cavity, holding this parking brake piston towards this housing against this spring pressure. Against this spring pressure, this parking brake piston is held towards this housing, maintaining a gap here with the oil pressure. So because of this, these clutch plates are free. When you apply the brake, you can see this figure, the oil pressure is maintained in this cavity as I told you. This when the vehicle is running. When you apply this brake, what happens? Oil pressure from brake circuit comes in this port. When you apply this brake, oil pressure from this circuit, oil pressure from the brake circuit comes through this port and creates the pressure behind this piston. behind this service brake piston, moving this piston forward. You can see the gap is increased here. You can see the gap is increased here when the oil pressure is acting on this piston. When this piston is moved forward, because after this piston, complete clutch pack is installed here. This clutch pack is installed here. This piston goes and presses this clutch pack, holding both friction plates and reaction plates together. So then what happens? Friction plates are mounted on a moving hub, whereas reaction plates are mounted on a stationary housing. When these are held together, the complete pack gets the braking effect because the steel plates or the reaction plates are mounted in a stationary housing. That's how when this pink piston is forced towards the clutch pack with the oil pressure, as and when the service brake is applied, the oil pressure from the brake circuit comes through this port and pushes the spring, holding this clutch pack together. That is both friction plates and reaction plates. That's how the brake is applied. Sooner you release the brake, because of this spring tension, because of this spring force, whatever is compressed here, internal spring, this service brake piston comes back to its original position. You can see this is the gap when the brake is applied. Here is the gap. Okay. So because of the moment oil pressure is released here, there is no gap. Because of this spring tension, the piston travels back to its original position, releasing the brakes. Let us see when the parking brake is applied or the machine is stopped. What happens when the machine is stopped or the parking brake is applied? Whatever the oil pressure was present in this cavity during the machine running, the pressure drops down. So during the application of the parking brake as well as the machine is stopped, so the oil pressure becomes zero. When the oil pressure becomes zero here, what happens? The pressure from these springs, these helical springs, acts on this parking brake piston. So oil pressure has reduced or become zero when the parking brake is applied or the machine is stopped. So the pressure from the springs pushes this parking brake, and also the service brake piston, which is behind the parking brake piston, pushes towards the clutch pack. So the complete both the pistons with the help of the springs are pushed towards the clutch pack. You can see there is no gap here. So when this piston is pushed here, as we talked earlier, when the service brake is applied, this piston is moving towards the clutch pack, holding both friction plates and reaction plates together, applying the brake. Same thing happens here. As long as the oil pressure is released from this cavity, the spring force will push these pistons to hold the brakes, which means in the OCDB machines, when the machines are stopped, the brake is always in engaged condition. When the parking brake also is applied, also the brake is in engaged condition. The brakes are released only when the machine is in running and the oil pressure is available in this cavity between this parking brake piston and this housing. So the oil pressure holds this piston towards this side, okay, against this spring pressure. The moment the machine is stopped or the parking brake is applied, the oil pressure becomes zero, forcing these piston springs to push these pistons together both towards the clutch pack. This is how happens in the OCDB. Now, as I told you, as long as the pump is running or the machinery is in continuously, the brake oil will be circulating in this between the clutch plates for the cooling purpose. The oil is entering here inside and passing through these grooves of the friction plates, cooling these clutch plates, absorbing the heat generated during the brake application as well as during the operation of this complete catchback. And the oil is going here, the heated oil is coming out of the housing and going to the cooler. Now what we discussed or what I explained is a very simple process of the oil-cooled disc brakes. Practically speaking, the machines equipped with oil-cooled disc brakes will have lot many safety features embedded in the system, including so many electronic sensors, so many other devices, valves and all. So many things are there. But as that is being a lengthy subject, I just explained you here in very brief way. However, anybody is interested to know more about the oil-cooled disc brakes in detail, they can always contact me through the email.